Hi, hello, greetings to everyone. Welcome back to my channel Physics Magic by Habib. So, let's start today's lesson. Power. Power is another very important concept. Mostly this year, we can expect the questions from power also because power is nothing but in many of power problems. Once again, we have to use work formulae, kinetic energy, potential energy, those formulae only. That's why power is very important concept. So let us see what is mean by power. So power is nothing but rate of doing work. Means at what rate that work is doing, that is nothing but power. So we can write power is equal to work done by time. So this can be generally directly power will not be asked. Generally two kinds of powers will be questioned in exams. One is average power, another one is instantaneous power. So let us discuss about those. So P average is equal to total work done by total time. That's it. Work done by time only. But average power, if anyone is asking you to calculate, find out the total work done and find out the total time. Just these two you do like this, automatically will be getting the power getting in this with this formula is average power. Now you know that from work energy theorem, total work done is nothing but what? Change in kinetic energy. So change in kinetic energy by total time will give you P average. So this is one important formula. So then the second one is instantaneous power. Means at any particular instant, if we want to find out the power, then how? So that formula is this one. P instantaneous is equal to limit delta t tends to 0 delta w by delta t. Means at any particular instant, if they are asking find out the power, then we have to use this particular formula. Average power already we calculated, so you got a high clarity on this. Then to find out this one, we will do like this. Then this can be written as dw by dt. Then you also know that dw is nothing but f bar dot ds bar divided by dt. And you also know that f bar dot ds bar by dt, that is nothing but power is equal to then f bar dot v bar, you got velocity because rate of displacement is called velocity. So we got ds by dt is nothing but v. So instantaneous power means at any particular instant, if they ask power, we have to use this formula. In this limit delta t tends to 0, delta w by delta t can be written as dw by dt for a small interval of time, and p is equal to dw is nothing but you know from your previous knowledge f bar dot ds bar and divided by dt. So this can be written like this also. Then ds by dt is nothing but velocity. So this is another form of instantaneous power formula. Further, I can write like this here: Fv cos theta, where theta is angle between force vector and velocity vector. And you also know that if theta is 0, cos 0 is equal to 1, power becomes maximum. And all this information you know here. Theta is angle between f bar and v bar. So you understood what is power and what is average power and what is instantaneous power, and in different form also we found. So with this help, with the help of this formula, you can happily do problems on the power. Now let us continue the same here. Power is equal to, we have written now instantaneous power is equal to dw by dt. So from this formula, you will be getting, if you draw a graph between work done and time, the slope of that graph will give you the instantaneous power. If you draw a graph between work done and time, then you will be getting a graph like that. Then the slope of that particular graph will give you instantaneous power. So P instantaneous is equal to this one. Now dW is equal to P into dt. You can write like this, dt if you take that side. Therefore work done is equal to integral P dt. Now one more important point you got here. That is, if PT graph is drawn, PT graph, this is WT graph. So WT graph, if you draw, slope of the graph, slope of work done time graph will give you the instantaneous power. Remember how important points you are getting. Who knows, you may get as a theory question also like this. The slope of work done time graph gives dash. Then if you are not aware of this, you may lose 4 marks there. Just remember, then W, yesterday I told you y component value by x component value is not change in y component value by change in x component value is nothing but slope. So slope I wrote here. So slope of WT graph will give you instantaneous power. Now from here only I further extended dW is equal to P dt. Then W is equal to differentiation I'm taking out means integration, integral P dt. So if you plot a graph between P and T, then what you will get here, the area under this PT if you draw. So like say for example, the area under this particular graph will give you work done. So area under PT graph gives work done. So in graphs you got 2 informations. From the first graph you will be getting, if you find the slope, it will give you instantaneous power. In this graph, if you find area under that graph, it will be, work done. So this is all about the introduction of the power. Now we will discuss some applications of the power, which are very important, and I will give you direct formula of that, and 100% it will help you. Let us see that. Now some applications of the power we will discuss. These are direct questions only. In the exam also you will be getting the questions like that only. So as I am giving brief information of every lesson, because this is not a regular class and this is not a regular teaching to give each and every concept in detail. Because of that reason I have given here the important applications of the power. Directly in the previous examinations questions came on this. So that's why these 4 formulae will help you a lot. So the first one is, if a machine gun fires n bullets, each of mass m with a velocity v in time interval t is given by, directly these values will be given. N value will be given, m value will be given, v value will be given, t value will be given, directly power will be asked. Then how to find that? Value here, change in kinetic energy by time. Then initially when bullet is not fired, then its kinetic energy is 0, initial kinetic energy. Then after firing, its velocity becomes v, then its kinetic energy is half mv square. Then you know that delta k, change in kinetic energy, final minus initial is 0. So half mv square minus 0 is half mv square. For one bullet half mv square, for n bullets n into half mv square divided by time. Then if you do this, happily you will get the answer. So directly, because these type of questions you will be getting minimum 12 to 15 on formula based in the NEET examination. So remember this. Then you go to the second one. Another very simple. A crane lifts a body of mass m with a constant velocity v from ground, then power of crane is equal to, say he only gave constant velocity. Constant velocity means power is equal to force into velocity, and force applied by the crane is equal to the gravitational force. How much force is there? With that much of force it has to apply on that. So power becomes now force into velocity, mg into v. This is also previously asked question. Then if you remember these formulae daily, if you study these kind of formulae, 100% it will help you. Then you go to the next question. Another very important application, power of lungs of a boy blowing a whistle. A boy is blowing a whistle, then what is his lungs power? Same formula, half mv square only. Half mv square by t. But m by t is written as mass of air blown per second. Second is time, mass is up. Mass of air blown per means by. So mass by time you are getting here into v square. It is nothing but half mv square by time. So this is another very important formula. Question will be given like that only. Mass of air blown per second they will give. Velocity will be given. So directly power you can find. Then next question. Power of human heart pumping blood or heart pumping blood is. You know well here human heart will pump the blood. Then what is the power of the heart? Because sometimes you know well heart becomes weak. Then they will feel lot of drowsiness, giddiness. So because of that reason, always power of the heart, if it is good, then automatically they will be very active. Now to find out the power of heart, this is also previously asked NEET question. In that one, P is equal to power, this one is equal to pressure into volume per second. So W will be written as pressure into volume also. You have one formula PV. W work done will be equal to product of pressure and volume. So from that you got per second means by time. So work done by time is nothing but power. So this formula will help you in finding the power here. So these are the four important applications. Then we will do some more applications now. Okay. Then some more applications. Look at this. This is also direct question only. If a motor lifts water of mass m from a well of depth h and delivers with a velocity v in time t, then power of motor is. Here the motor is doing two works. It is lifting the water from the well and it is throwing out, pumping out. So in lifting it is doing some work and in pumping out also it is doing some work. So the total work done is nothing but how much work it is doing in lifting and how much work it is doing in delivering. So that's the reason why the work done in lifting means you know earlier potential energy plus in discharging or delivering out with a velocity v means half mv square. It's a kinetic energy it is giving to the water. So the total work done will be equal to mgh plus half mv square divided by the total time taken is t. So this is also another important formula. Values will be given. We have to substitute and calculate that. Then another very important question is, if P is rated power of a device, if its efficiency is X%, then useful power is very simple. Okay, it is equal to X by 100 of P. For example, a motor is rated as 100 watts. Its power is 100, but its efficiency is 50% only. So it can perform only 50% of its capacity. Its efficiency is 50%. Then what is output power you will get? Only 50% of that. 50 by 100 into 100. Original power is 100. Rated power is 100. So but its efficiency 50%. So 50 by 100 into its power is 100. 100 gets cancelled. So the output power will get only 50 watts. So this is another important model. Then finally, another very crucial question. When a liquid of density rho coming out of a hose pipe of area of cross section A with a velocity v strikes the wall and stops dead. So this is a hose pipe and from here a liquid is coming out. The density of the liquid is given, area of cross section of the pipe is given, and it is hitting the wall and stops dead, means flying down, falling down. So the power exerted by the liquid is how much power it is exerting. To find that, here the total work will be kinetic energy only. So half mv square by t. But here mass of the liquid we have to find. For that, mass is equal to volume into density. Density of the liquid he gave. So volume into density into V square by time. But volume is nothing but area of pipe is A. Then into length of the pipe is say L. Even though it is not mentioned, but we will take that. But later on, in the final L we won't use. That's why let us suppose L is the length of the pipe, A be the area of the pipe, then the volume of the pipe will be A into L. Rho we have written, V square we have written, T we have written. But L by T is nothing but, look at this here, L by T, distance by time. So it is traveling from here to here. This is length of the pipe and it is traveling the same distance. So distance by time is nothing but velocity. Already V square is there. Here I will write here, since L by T is nothing but velocity. Already V square is there. This velocity will join. Then it is V cube, rho A V cube. This is the power exerted by the liquid. This is another very important application. All the data will be given and you will be asked this question. And this is also, this mass by time is nothing but mass rate flow. And based on this one also questions will be asked. We will see in the next applications. Okay. This is another very, very important concept, and with this, the power concept I will finish. And in this one, a body of mass m accelerated starting from rest while the engine supplies constant power. Very, very important. Then how its acceleration, velocity, position varies with the time. Previously asked questions, all these. So here I will do derivation. You are not supposed to remember the derivation, but finally how acceleration varies with the time and how velocity changes with the time, how position changes with the time. These three formulae, if you remember, happily you will get 4 marks. As it is, they will ask only how to identify. So just let us see now. Actually, he gave power is equal to, you know well here, force into velocity. Then this gives you force is equal to power by velocity. But F is equal to ma. So ma is equal to power by velocity. And that gives A is equal to P by mv. Then A is nothing but dV by dt. But this is equal to dV by dt is equal to P by mv. Then rearrange this. V you bring this side, dt you take that side. V dV is equal to, V brought to this side, dt will go that side. It is Pm by dt. So V is taken to this side, dt is taken to that side. Now integrate on both sides. Integration if you do, directly I am writing here because this is not required the derivation. Directly I am doing. So it is nothing but V square by 2. Limits if you apply 0 to V only. So V dV is nothing but V square by 2 plus constant we have to write in integration. But if you take initial values, the constant also will become 0. That's why I am not taking any integration constant here. Directly I am writing V square by 2 is equal to P by M into T. Integral dt is nothing but T. P by M is constant. P is power. Power is constant. M, mass of the body will not change. So this is constant. Written outside, integral dt is nothing but T. We got the relation. Therefore, V is equal to, V square is equal to, in fact, 2P by M into T. There it gives V is equal to 2P by M under root T power half. Let's here. Square I am taking out here. So here it will come root and T power half or root T. So we got V relation is T power half. Then we got here. Then I can write here. Therefore, V is directly proportional to T power half. So we got velocity time relation we got. So in the exam, if you get directly this option, you tick it, get 4 marks. No need to do all this derivation. But I have to explain. There's a reason why I explained this one. Then V and A are opposite, reverse. You can say one is in the numerator, another one is in the denominator. Then if it is t power half means A is proportional to t power minus half, direct. Because these two are reverse. Then denominator goes up, then plus will become minus. So plus becomes minus. Over. Now displacement means from here only we will be getting V is nothing but dx by dt is equal to under root of 2p by m into t power half. Once again dt you take that side, then integration on both sides. Integral dx is equal to under root of 2p by m constant, writing outside integral t half into dt. So dx I am keeping here only, dt I am taking this side and integrating on both sides. As 2p by m is constant, I am taking out. Now integral dx is nothing but x, and this is constant, I have to write like that only. And t power half means you know well, the integration means power plus 1 divided by whole we have to write in the denominator. So t power 1 plus 2 plus 1 is nothing but 3 by 2. The same 3 by 2 you write here, then it will become 2 by 3. 3 by 2, if you rearrange, you will be getting here 2 by 3. So I hope you understood. Integral x power n is n plus 1 divided by n plus 1. So 1 plus 2, 1 by 2 plus 1 is nothing but 3 by 2 divided by 3 by 2. But that 3 by 2 if I write, I got it 2 by 3. Therefore x, this is constant, this is constant. So x is proportional to t power 3 by 2. We got all the three relations we got. Velocity we got, acceleration we got, and position we got. So no need to do anything. You are not supposed to do any derivation in the exam. But just simply you remember, then when this case is given, case is fixed, like that only you will get the question. In that question, so if you get like this, all this derivation for your understanding purpose I did. But you remember only these boxes. Velocity is directly proportional to t power half, and acceleration is t power minus half, and the distance is t power 3 by 2. These three if you remember, then 4 marks just like that you will get. Just keep this in your mind and practice once again. With this, the power concept is completed. All applications also I told you. Then if you work out on this, how many problems you can able to do. Then in the next and the last lesson, I am going to explain some numericals on work energy theorem, law of conservation of energy and power. So students, so far 5 lessons are finished, and these 5 lessons if you are thoroughly revising and are writing all the formulae on your sheet, and if you revise many times, 200% I can assure you, work power energy will give you 100% good marks in the 2020 NEET examination. I wish you good luck, practice, do work hard, all the very best, and have a nice time.